Okay, so let's talk about. Okay, let me do the topic. Okay, so let's talk about our topic, which is regarding energy level. Okay, now energy level is a very interesting topic in the world of quantum mechanics or in physics and chemistry because it it defines each particle, each element. Okay, now what I mean by each element is that, let's suppose if we have element sulfur, I'm not supposing, it's not real. If we have an element sulfur and we have certain energy levels in it, okay? Now, what's so special about these energy levels is that they are fixed levels, okay? That means they can neither change for sulfur, neither they can have extra energy levels in between or outside them. So these cannot have if this is over here for sulfur, it will stay here for sulfur. This will be sulfurs, this will be sulfurs, and this will be sulfur. Okay, if I take another element, let's suppose phosphorus, or let's take oxygen. Sorry, oxygen, and oxygen's energy levels maybe are this, this, and this. So there is a huge change, a huge difference between these two. There's a huge gap here, huge gap. Okay, okay, and these are energy levels 1, 2, and 3. 1, 2, 3, 4. Okay, so you might have guessed it right. Yes, because for each element has, oh sorry, uh has different levels. Okay, so there's a differ in the size and energy levels in uh, from element to element. So when we talk about how electrons from this state, the most bottom one is known as the ground state, the ground state. Okay, the excited state, and all other stages over here, all other stages are known as are known as excited state, excited state. Okay, now uh, these are known as excited states. So electron can go from this one to this energy state, and from this to this energy state, from this energy state. Okay, 1, 2, 3. Okay, so um look, so if this is one energy level, now look at this amount of energy which each level requires. So that means that if we have a photon, because that's what electron observes, to absorbs and emit to rise and decrease in level, so which is hf in simple form, the energy which the electrons take in. Now, important thing about this energy levels in elements are that um, for electron to jump from each stage, it must it it must have the exact amount of energy. Okay, so that means if this photon over here wants if this photon gets hits this electron at in this state, and which is from this state, and if that electron jumps from this part of the level to this part, okay, that means 4 minus 2. Well, it should be actually like this. It's 2 minus 4 ev, which means minus 2 ev. We will ignore minus for now. So it means that this photon must have 2 ev, 2 joule, 2 times 10 to the power 2 times 1.6 times 10 to the power minus 19 amount of joules for this photon to make this electron jump from the ground state to which state is this? Second level of energy, second energy level. Okay, so it must have exactly the same amount of energy for the photon must have that same amount of energy for the electron to jump from the lower state to higher state. But the condition is that if it has energy either lowered exactly by or like exactly mean any other value other than the values required to jump from these in these levels, there will be there will be no excitation. Excitation means no rising of the electron in levels. Excitation. Okay, now this equation which I wrote over here, hf is nothing but hc over lambda. Both can be fine, both are the same equation. It's just f is expanded to c over lambda. C is speed of light, h is Planck's constant. Okay, now when we talk about the equation hf and hc over lambda, and these are what? These are energy levels, or energies, right? There's not an energy, it gives energy. Now, if we talk about, let's suppose, if there's a particle which is there's an electron over here in third state, and it goes from this part of the level or this level to the bottom level. This is the ground state. Ground state. Okay, now if what's so special about this electron is this jump is that if this jump, now first of all let's see if it's a absorption or emission. When we talk about absorption means increase in energy, and when electrons get increased in energy, they jump, they get a kinetic energy or more energy to rise in level. So it's not absorption, it's emission. As in electron lost its energy, it will go to a lower energy level. Okay, now that since we will label this as emission. So we must know what emission and absorption's difference are when increasing and decreasing of level. And also you might have noticed electron can not only jump from level to level, but it can also jump with more than one level. If it has that amount, that exact amount for it to jump 2 levels up, if electron has energy for one level, then only one level will be raised. But if it has if it has more than that amount of energy, enough to jump enough to jump, let's suppose enough to jump from this state, or it's not jump, it's actually decrease, it is a jump to this state, fall, I would say fall. So it must have that exact amount, neither less neither more. That exact amount must be there of energy by the photon. Okay, now uh, even using these equations, these energy levels. We can also tell what's the wavelength of that photon. Yes, wavelength or frequency of that photon. Okay, now look at this equation over here. We'll now for only now we'll talk about wavelength. We'll not talk about frequency. So look at this equation. In this equation, energy is inversely proportional to wavelength. And if I have a question that if there is these, let me say, if there are these, wait. Let's assume this one. Yeah. Now, now here if I'm asked a question, and let me remove this one and add one more level and then make an arrow over here. Okay, now if I'm asked from these electron emissions, okay, these energy levels decreasing, which photon, because it's emission, right? Emission means the photons emitted. Now which photon from these three, photon emitted by these three electrons, which which will have more lambda or wavelength. Now that depends on the height difference. Okay, i'll I'm like talking about in simplest form, height difference. Now meaning if we want the wavelength to be to be more, be the largest, we will look at energy difference, which is a lot. Oh no, the largest, right? So it means the one with the least energy difference, because this energy over here, hc over hf, is nothing but e2 minus e1. So the difference, the more the difference, more or more or less, I'll just write both, more or less will result, sorry, will result in more or less wavelength. Okay, as it's now it's vice versa. So that means less means more, more means less. Make it simplified: more, less, more, yes, less. Now this is how it goes. Now uh one more example of, like, one more important, and the simplest experiment of this is hydrogen, using hydrogen element. Okay, because it has the easiest, it's easy to make show energy levels of hydrogen. So what else was there? Was I Did I miss something? This and this. And then about the energy levels of this, by the way, this wait, did I? Yeah, I didn't. So this 2 eV or 1 eV, with the word eV is nothing but one way to write energy. So if you want the energy in joules, you can just take that eV, whatever the values over here, times it with 1.6 times 10 to the power minus 19 joules, and you get the energy in joules. That's how you could get the energy in joules. Now, because uh, what else? What else could we have now? What else do we have? Energy level increase or decrease, and it depends on whether you have a more energy level, less energy level, and this is not this. Everything comes in spectra of light, or energy spectra, not spectra of light, energy spectra, because it makes a certain amount of spectra. So let's suppose if we have a for those which have absorption, we will have spectra of colored spectras. But when we talk about emission of photon in an electron decreasing, which is emission of photon, that we will have a black line spectra. So let me write something over here, and I just don't want to go to the page. And let me just zoom in. And what else we have is no. Okay. And then black line spectra. Black line spectra is emission, sorry, of photon and color is absorption of photon. Now, um, other than that, what we talk about is okay. So, and I did write over here E is equals to difference. This E2 minus E1 is a difference, and in simple form we write at E. When we're given the value E, the difference is already there. We don't have to calculate difference. But yeah, so there's one more unique point over here is that when I was talking about when I over here I made two electrons in the same level, and that's one of the important points in this in this like chapter is that when we talk, it's not like regarding the energy levels, but it could be there is that if two electrons are in the same orbit, the condition for them must be that they must sorry they must have something different. They must have a a difference in properties. Okay, difference in properties. They must have a different property in between them. Okay, maybe this one has quantum number n, this has quantum number 1, and this has quantum number 2. But if let's suppose there's two in which they have if they have the same spin, let's suppose these two electrons have the same spin, 1 by 2 and 1 by 2, okay, plus minus plus plus, then what that will do, there will be another something else which is different, which is about the spin. Maybe the spin is different, orbital spin is different, so they must have something different in between them for them to coexist in one state or in one energy level. This is how I describe, this is how we describe energy levels in the for explanation, but actually this is what energy levels actually looks like. This is our energy level. This is the nucleus, these are the orbits of the electron. So this is electron in this energy level, and this is the ground state. That's how energy levels look like. And yeah, that's it. Thank you.